And that's exactly what we need to do. We kind of need to like separate them. We have to put the y's separate from the x's. Okay, now there's some options here, but most students are going to say, why don't we shift the y's over here, and that way we can kind of shift everything else to the other side. I would agree, but do you understand why I'm doing this? It's so I can put the y's together. Now, if you're saying, but Mr. Miller, there's an x coming with it. Okay, it's got to come with it, but at least I'm going to put all the y's on the right-hand side and, well, whatever else we can get on the left side. Take a look. It's just some adding and subtracting. The only stuff that moved were in yellow. All right, so x plus 3 kind of hanging out over here, and then we got our y's over here. Okay, and we kind of get to the crucial step of the problem. It's something from algebra, and it pops up at various times whenever you have what I like to call a repeated variable. A repeated variable. There's a little technique that you pull out of the bag of tricks. Did you reach in the algebra bag of tricks and you pull out factoring? Factoring. If you're not sure what the language is, were you thinking about that procedure? It's called factoring. You take out the repeated factor. So I factor out a y. Take a look at what you're left with. Are you surprised? It's 1 minus 2x. Okay, now what just happened there is the repeated variable, which kind of was bugging us from the beginning. So we had 2 y's from the beginning. Now is just 1 y. Okay, again, all brought to you by factoring. All right, of course, you divide both sides by this quantity. So we divide both sides by 1 minus 2x. Understand as you do that you're doing it to solve for y. And that is your inverse. Nice to label it that way, f to the negative 1. But f to the negative 1 of x is x plus 3 over 1 minus 2x. Okay, kind of feeling like all of a sudden you step back into algebra class. A lot of algebra in calculus. Okay, you guys will keep learning about algebra. A lot of it seems to do with fractions, but it's just true. So here's some nice manipulating. So what's kind of the big deal about this answer? Okay, well, it's all these things. Okay, first of all, it would be symmetric with the line y equals x. Now this is, I'll be honest, it's almost like not really helpful. I'm still going to show it to you, but it's not really helpful because the graph is so complex that it's hard to see the symmetry. Just by the way, as you become a student of your calculator, you can always play along and don't feel bad about asking questions. Sometimes people just want to know why I'm skipping space. I like to double space so it sort of spreads it out for you guys. Okay. Also notice I typed in x. Oh, the line of symmetry. Here's the truth though. This is going to be, again, just sort of messy. Let me make the inverse bold. Some of you guys with other calculators, maybe you make it green or something, green or blue. But anyway, here comes the inverse. I guess it's not too bad. If you take this branch right here in purple and you fold it over the diagonal line, it's going to now fold and be this branch, the thick branch. So it's not too bad, I guess. You can fold this other branch and it'll fold over there. It's hard to see the symmetry though. What about the composition? What about the composition? Okay, the composition is more going to be the method that you guys use on your assignment to verify. Just by the way, even though this is not a great problem, if you're supposed to be drawing a graph on your assignment because it says so, then you draw it. Okay, you actually have to put it in your assignment. You use your calculator, but you still sketch it in your assignment. There'll be plenty of times when you do that this year. Not that problem. You're not going to sketch that. You are going to verify with some composition. Now, this is going to be a bucket of fun, but let's do it. Okay, it kind of shows you that when you get to something like this in your assignment, you don't skip it. Okay, you kind of take the plunge. F of inverse, I mean, we can call it f of g, or we can call it f of f inverse. Here's your inverse. Kind of try to box it up a little bit here. We're going to box it up and we're going to send it into the original function. So those two x's, oh, yep, both those x's are going to get replaced with this fraction. Just want you to see that so far I put it in the numerator. Okay, so far I put it in the numerator. But yeah, that means I put a fraction in a fraction. I still have to put it in the denominator. I don't know where you're at with this problem. Maybe you're kind of like just kind of waiting for me, and I'm happy to show you. But I would like you to realize before we go any further, like what we hope is going to happen here. We hope it's going to cancel to be x. Okay, but you have to show it. You can't just say, okay, you can't just say it. You have to show it. Okay, that means you got to do some algebra. All right, now, the reason I'm going over this problem is because I want you guys to realize that you can do this algebra. Maybe you need a little bit encouragement, but how to take a fraction and subtract a whole number? Well, you need a common denominator. Okay, now the common denominator is what has to be the 1 minus 2x. But I'm sure that's not the first time you've seen the use of a common denominator algebraically. It shouldn't be, but look, you just multiply the top and bottom by 1 minus 2x. I know, it gets kind of big and bad, and you're making it a little bit worse before it gets better. Okay, now, careful about stuff like this. It's just one of those things. You're actually distributing a negative 3. You're distributing a negative 3. So you get negative 3 plus 6x. Now I'm trying to do a little bit of this in my head because it looks like we're going to get a plus 6x plus this x. Okay, when it's all said and done, that'll give us 7x. We're going to get a negative 3 plus 3. Oh, that cancels out. I don't know if you want to write 0. I just feel like we need to put something in that space, but the 3's cancel out. Just kind of wondering, do you want to try to mess around with the other half of this? Maybe you don't, but trying to give you a chance to do a common denominator. Okay, if you're a little bugged by this 2 out here, it does not affect the denominator. This 2 is ultimately going to give us a 2x and a 6. Okay? Can you make this 1 join the fun? Can you make it have a common denominator? Feel free to look up here. I would like you to be able to keep going. If you were a little stuck on just the common denominator, I did it in orange there. Okay, so you're trying to add the like terms. I think we're going to get some x-like terms. There's actually a 2x and looks like a negative 2x. You only do this a couple times. You start to kind of anticipate things canceling. Okay, but don't just cancel everything out. But that's a good sign. 2x and negative 2x become 0x. Okay, we also have a 6. Okay, that came from distributing this 2. So we have a 6 and a 1. 6 and 1 are 7. Common denominator is still the denominator. Okay, now what we're really looking at here is 7x over 1 minus 2x divided by 7 over 1 minus 2x. I didn't really do much there except get rid of some of the extra space, kind of make it look a little cleaner. It's another good opportunity for us to talk about how do you take a fraction divided by a fraction? How do you take this fraction divided by this fraction? Okay, well, I would say you don't. Instead, you multiply by the reciprocal. So this fraction divided by this fraction is actually this fraction times the reciprocal of this fraction times the reciprocal of this fraction. Now, just again, it depends on the student, depends on the problem. It always depends. But do you need to write some additional things down? Do you need to say, like, what happened here? Are you organizing your notes that you can put something in the margin, that we multiplied by the reciprocal? Again, do you need to write that? Over here, we made a common denominator. When you look back at your notes, will they be helpful? Or maybe just hearing this is all you need. Okay, but this is a good sign. Okay, those are now clearly going to divide out, cancel. These 7s are also going to divide out, cancel. Okay, now we showed enough work. Now we showed enough work to end up with x. Okay, I get it. It's not like someone's going to use that in their job. Okay, nobody's going to use that in their job, okay, unless maybe you're a math teacher. But it's the theory behind what's happening here with the numbers. And when you have things called inverses, now those concepts can be used in the real world. But when you have things like inverses, they undo themselves. They cancel each other out, okay, to be x. And that's what you're proving. Okay, and I know you'll see some stuff like that in the assignment. Okay, and again, just speaking of the assignment, always follow the book's directions unless I say otherwise. I'm just sharing that because the book's going to say find the inverse, which you're all going to do, but it's also going to say verify it, which I hope you're all going to do. And if it says to do it, that's part of the problem. It's not like just kind of extra. Okay, now we did verify a problem last week with a graph, but this one we kind of suggested that the function composition would be better. All right. I was actually looking at my notes here. I actually have another one to do, but it's a segue. So yes, we're going to do another one. It's not going to be like what we just did there, but it's actually a segue into a little different conversation, which we'll have mainly after lunch. But what if I gave you this function? So e to the x minus 3. E to the x minus 3. Now, it also is not just kind of your run-of-the-mill equation. It's not a parabola. It's also not a rational function. It's exponential. It's exponential. Let's switch x and y. Okay, we should still be able to do that. So we had x equals e to the y. minus 3. X equals e to the y minus 3. Now remember, your goal is to solve for y. Okay, your goal is to solve for y. It should be pretty easy peasy stuff here. Add 3 to both sides. Add 3 to both sides as you solve for y. But look at y up there. It's almost kind of like teasing you. Yeah. Look at me up here. Look at it. Don't you just want to like get it out of the exponent? Don't you just want to slap it with a log? Okay, I do too. Okay, because it's up there saying you can't get me until I slap it with. Now, what kind of log do you slap it with when it's e? Natural log. And you saw this. We did it sometime last week, but here's a little application for it. So we slap it with a natural log. Some of you are using stuff like that in chemistry. Okay, natural logs definitely pop up. But now we solved it for y. And again, I'm just kind of standing here saying, expect to do some things like this, like use a variety of algebra. Okay, and I'm going to label it. That's good. That shows that you know what's going on. So call it the inverse equaling ln of x plus 3. I should have did this before we started the problem, but it'll still be fine. I should have graphed this. I saw some of you actually graphing it. That was good. We should have graphed e to the x minus 3. So how do you graph e to the x minus 3? Well, without your calculator, and you're going to be doing some of this in your assignment, remember, you have an asymptote. Okay, you have an asymptote. You also have a y-intercept. Now, there's different ways to think about the y-intercept. You can think about it as starting at 1, and then shifting down 3. You can also think of it as plugging in a 0. If I plug in a 0, I actually still end up with 1 minus 3. Okay? Either way, we get at negative 2. Now remember, E is a growth base. So we get ourselves a nice little exponential growth. Now, like I said, we could have, should have graphed that before we started the problem because it's 1 to 1, you know, and now we actually can find the answer. But we found the answer. It's the ln. So here's the little segue. Let's talk about this a little bit before you break. What's the graph of ln look like? Okay, now that's usually a pretty good question because it's not just a little parabola that everybody knows. It's an ln. Okay, but the good news is it's just the reflection. It's just the reflection of this growth graph. Okay, and I say it that way because I would expect that you guys can start to see some of that reflection. Let's see it. You switch x and y. Okay, like literally I can switch this y-intercept to be an x-intercept. That's cool. Just got to write it correctly. What else switches? Okay, what else switches? Well, the asymptote switches from y equals to be x equals. Are you surprised? X equals is a vertical asymptote. Okay, now remember what's happening here. We're graphing a logarithm, but we're kind of graphing it through symmetry. And I guess it gets to that point where you have to be able to draw some symmetry. This like sort of half moon, sort of this crescent shape is going to reflect, and it's now going to be curved that way. This part that was shooting up exponentially is now going to actually be shooting more horizontally. It's not perfectly horizontal, but we reflect that, and then you can reflect this piece here to actually approach the asymptote. Now that yellow graph right there, that's the graph of a natural log, okay, which by the way has shifted 3 units to the left. It has shifted 3 units to the left. As I write that down, though, I hope you realize that that's another way to think about this x-intercept. After lunch, we'll talk a little bit more about everybody's favorite, the graph of a logarithm, okay, and some other things with logs. Okay, we're kind of sneaking logarithms into this section, as that's what the book also does.